In this video, this is the second part of lesson 6.1. It's part 2. It's about systems of linear equations in the real world. This is applying systems of equations to real world situations. Okay, so our objective is I will write a system of linear equations to represent real world situations. I will write a system of linear equations to represent real world situations. Okay, in the real world, the slope m is always the rate. Okay, the rate like something per something. The y-intercept always means the initial value. Okay, it could be the initial weight, the initial cost, the initial length. It's the initial something. All right, our essential question is, what does a system of linear equations allow you to describe? Okay, how can you apply it to the real world? Let's look at example number 1. It says, marine biologists studied the lengths of 2 species of shark for several years. The initial length and growth rate of each species are shown in the table. Write a system of equations that biologists could use to compare the lengths of the 2 species. Okay, well, first we have to figure out, what are we looking for here? What are we comparing? What are we setting the equation equal to? And here's the key word. They're asking us to compare lengths, which we could call L. L could be the length. The length in what? Is it meters? Is it inches? Well, we want to look at our chart here. The initial length, the length is in centimeters. It actually tells us that in our chart. So we want to write equations comparing the lengths in centimeters. Okay. As you notice, the initial length, remember we talked about what words mean in the real world? The initial length is going to be the y-intercept in your equation. That's what it starts at. It tells us the Greenland shark starts at 37 centimeters. That's your initial. Then the rate of growth, which is your slope, is 0.75 centimeters per year. Notice it's something per something. So the first variable, we're talking about length in centimeters. The way that you're going to get your other variable for your equation is you look at the units for the rate. Centimeters is our first variable. Years is going to be our second variable. Okay, because remember, linear equations have 2 variables. So, in this case, we have centimeters and years. L is going to represent length in centimeters, and then years, let's say T for time in years. Okay, now that we have both variables for our linear equations, we need to set up a system of linear equations. All right, we need to set up an equation for each shark. We have the Greenland shark and the spiny dogfish shark. So let's say the spiny dogfish, the Greenland the Greenland shark, we need to set up an equation. And then the spiny dogfish shark, we need to set up an equation for that. Okay, the Greenland shark, right, if we're going to use our slope-intercept form, y equals mx plus b, well, we know that we're looking for the length, L equals, it starts at 37 centimeters, that's our y-intercept, 37 plus 0.75 t. Right, the length is going to be, well, it starts at 37 centimeters, and then you're adding 0.75 centimeters every year. The slope is always the number with the other variable. In this case, it's years. All right, the spiny dogfish shark, it's saying the initial length here is 22 centimeters. So the length is going to be L equals, it starts at 22 centimeters when the biologist started studying the lengths. And then we're adding on, here's our rate, 1.5 centimeters per year, 1.5 t, because remember, t is the time in years. Okay, now that we got both of our equations, we can set up a system by just putting, remember, a system of linear equations is just when you have two equations together. Okay, so the system of linear equations would be, I'll write it up here, L equals 37 plus 0.75 t, and then L equals 22 plus 1.5 t. All I'm doing is I'm recopying my equations, and I'm putting them together to make it a system. All right, so here's our system of linear equations. Now what I want you to do is I want you to try the U-try number 1. And after you finish the U-try, you can go and watch the video labeled Lesson 6.1 Part 2, Systems of Linear Equations, U-try number 1. Okay. To make sure that you have the correct answer for the U-try.